Example 6 is our last example for section 3.5 on graphing using transformations. In this example, the parent function is the absolute value function. Now let's look at this g of x. We're looking for transformations, but notice once we get inside the function, inside the absolute value, it doesn't quite look like what we might be expecting. Instead of an x plus or an x minus something, we have 1 minus x. So before we go any further, let's talk about what that might mean if we had 1 minus x inside the absolute value. Is there another way we could write that where we could understand it as our horizontal shift? Well, let's just put a number in there. What if we had 1 minus 5? Then that would be the absolute value of negative 4, and that would be 4. How would that be different if we switched the places and we put 5 minus 1? Well, that would be the absolute value of 4, which is also 4. So switching inside the absolute value, if it's subtraction, switching the place of the two terms doesn't change its overall meaning, right? So we could rewrite this into a format that makes sense to us and what we've learned about transformations. So let's do that. Negative 2 times 1 minus x would be the same as x minus 1 for any value we would put in there, right? Put in any value for x, and it doesn't matter which way it goes. We can't change it to addition. That wouldn't work. But switching the place of the two terms makes no difference because once you take the absolute value, you'll get the same result. So this is what we're dealing with. All right, so our first transformation we see is a vertical flip, which means our y's will change sign. We'll multiply y by negative 1. The second one we see is a vertical stretch, which means we'll multiply y by 2. So in essence, we're going to be multiplying y by negative 2. We have a horizontal shift. Which direction? X minus 1, right 1. That means add 1 to x. And finally, a vertical shift down 4. Which means subtract 4 from y, which of course we do after the multiplying because of order of operations. All right, so let's get our ordered pairs for f of x. What do we usually use for absolute value? I think I've been using negative 2. Absolute value negative 2 is positive 2. Negative 1 to get 1. 0, 0. 1, 1. And 2, 2. To make a nice graph, I've got these 5 points. It says at least 3, but it's going to take 5 for me to make a nice graph. Okay, now our g of x. Okay, so what are we doing to x? We're just adding 1. So let's get those x's. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Okay, for our y values, we said we're going to multiply by negative 2 and then subtract 4. I'm just going to make a note here. Negative 2 times y minus 4. That's how I'm going to get my y's. Negative 2 times 2 is negative 4. Minus 4 is negative 8. Negative 2 times 1 is negative 2. Minus 4 is negative 6. Negative 2 times 0 is 0. Minus 4 is negative 4. Negative times 1 is negative 2. Minus 4 is negative 6. And this is negative 8. Okay, so that's the transformation of these ordered pairs. Let's graph our parent function. Negative 2, positive 2. Negative 1, positive 1, 0, 0, 1, 1, 2, 2. That's that parent function for the absolute value. Has these two 45-degree lines going through quadrants 1 and 2. All right, we're supposed to flip vertically, stretch, shift to the right, and shift down. Let's see if that's what happens. Negative 2, 2 is now at negative 1, negative 8. Negative 1, 1 is now at 0, negative 6. The 0, 0 is now at 1, negative 4. 1, 1 is now at 2, negative 6. And 2, 2 is now at 3, negative 8. Okay. So we see our parent function has definitely flipped vertically. It is stretched. In other words, vertically, the legs or the branches have been pulled on, which makes them come closer together and stretch. We've shifted horizontally to the right and down 4. All right, let's talk about the domain of our original parent function. What is the domain of f of x? Yes, all real numbers. How about the range? How low do we go in the y direction? Just to 0, right? And then to positive infinity for our parent function. All right, let's look at the domain for g of x. Well, it's the same, isn't it? We haven't changed that domain. Still all real numbers. How about the range? Low to high, what are our y values? Yes, negative infinity. And how high do we go in the y direction? Looks like we get as high as negative 4 before we have to turn around and come back down.